Here we are. We finally made it to stoichiometry. Stoichiometry is the fun part of chemistry. Now, this particular lesson is very important. You'll see the concept of stoichiometry appear in many lessons throughout your chemistry classes, courses, or career. So you definitely want to make sure you understand the foundations for stoichiometry. Now, what is stoichiometry? Well, it's the relationship between the relative quantities of substances in a chemical reaction. So what exactly does that mean? The relationship is going to be your ratio. Now, if you remember from balancing equations, we added some coefficients to make everything even so we could follow the law of conservation of mass. Well, stoichiometry uses that. Those balanced equations are going to give you this ratio. These relative quantities of substance is going to be your moles. If you remember when we did mole conversions, we had to do that because we can't compare the mass of multiple substances. We have to look at the quantity of atoms for a substance due to the nature of those atoms, since they got different numbers of protons, electrons, and neutrons. We have to compare a specific number of atoms instead of the masses. So we'll have to do a lot of mole conversions in this. And these substances that we're going to be using are going to be reactants and products, basically compounds in a chemical reaction. So a simpler, easier definition that I like is stoichiometry is the ratio of moles in a reaction. Very simple definition. I like it a little bit better, but that's not textbook definition. So use it if you will, or not, your choice. When starting out, students typically have some trouble doing stoichiometry because it does take a little bit of getting used to, but once you got it, it's easy. It's super easy to do. But just to start off, let's keep a simple example. We'll use the classic hamburger example. So in order to make a hamburger, you need a few things. So I need a set of buns. So I got top and bottom buns. I need a hamburger patty. And I like mine with cheese, so I'm going to put a little bit of cheese on there. We're going to do 2 pieces of cheese. I like a lot of cheese. So if I take this hamburger bun, we'll put some little sesame seeds on there. If I take this hamburger bun and I mix it with a hamburger patty, add some cheese, then I should get a cheeseburger, just a plain old cheeseburger. Draw that in there. Hopefully my drawing doesn't put anybody off too badly. I know it's not the best, but we try. So there's my hamburger. So it takes 1 bun, 1 patty, plus 2 cheeses, and I get a hamburger, a cheeseburger. So that in its very essence is stoichiometry. You got your ratio 1 to 1 to 2 to produce 1 hamburger. Stoichiometry follows just a very simple step-by-step method. Your first step is convert to moles. Whatever unit of measure you're given, whether it be grams or liters or atoms, you want to convert it to moles so you can use your balanced equation, which gives you the mole ratio. Step 2 is multiply by the mole ratio. And again, that is that balanced equation. And then the third step is convert moles to unit of interest. And what I mean by unit of interest is you just convert those moles back to whatever unit of measure that you're needing is, whether it be grams or liters or what have you. So the best way to do stoichiometry is just practice it. Just jump straight into it. So that's what we'll do. We'll just jump straight on into it. So our first one is pretty simple. We're doing a mole to mole conversion. That's stoichiometry at its simplest form. So how many moles of water can be produced from 5 moles of hydrogen gas and plenty of oxygen gas? Sometimes your reactions will be written for you, sometimes they won't be. I'm going to go ahead and write your reaction for it. But if you can't tell, knowing your nomenclature, reaction types And balancing equations will play a big role in your ability to do stoichiometry. And if you're not confident or comfortable with things like nomenclature or balanced equations, I recommend going back and watching some of our videos for it, or there's also some pretty high quality videos elsewhere on the internet that you can watch. But you definitely want to make sure you're good with nomenclature and balanced equations when you tackle stoichiometry. Alright, so let's see if we can figure this out now that we got our balanced equation written. So how many moles of water can be produced? So we're looking for moles of water. We want to know how many moles of water will be produced from 5 moles of oxygen gas. So H2 is oxygen gas, and we got 5 moles. We got plenty of oxygen gas. That means it's in excess. We don't got to worry about oxygen gas. So we're going from hydrogen gas to water. So we need to set up our dimensional analysis. So I have 5 moles of H2. I stick that over 1. I'm going to multiply it by the balanced equation ratio. Or to say I need to change this moles of H2 to moles of water. So I do moles of H2 on bottom to cancel it out on top over here. And moles of H2O go on top because that's where I want to get to. Now I use my balanced equation to get these two values here. My balanced equation says there's 2 hydrogen gas molecules for every 2 water molecules. So I put 2 moles of H2. I got that 2 from right here. And I got 2 water molecules. So the 2 goes right here. So 2 moles of H2O. And I got that from that balanced equation. So this ratio between hydrogen and water is a 2 to 2 ratio. There is 1 hydrogen for every 1 water. So now we can just do the math. 5 times 2 is 10, divided by 2 is back to 5. 5 what though? 5 moles of H2 cancels out, and it leaves me with moles of H2O. And there is our answer. Pretty simple. That was a mole to mole conversion. Those are the simplest. You probably won't get to see those a lot, unfortunately, but if you can understand that, then you're well on your way to understanding stoichiometry at its fullest. Let's do another one. How many grams of oxygen gas will be produced from 50 grams of potassium chlorate? Alright, let's set that reaction up. So we're going to have potassium chlorate. And it's going to decompose into potassium chloride and oxygen gas. Need to make sure our equation is balanced, which it's not. So I got 3 oxygens. I got 2 oxygens. We'll stick a 2 right here. It gives me 2 times 3 is 6 oxygens. 3 goes here. Now I got 6 oxygens. 2 potassium, 1 potassium. 2 chlorine, 1 chlorine. Stick a 2 right there. Fixes that problem. Now we're balanced. And that balanced equation gives us our mole ratios. So how many grams of oxygen gas will we produce? So at some point we're going to have to do a mole conversion to do moles to grams. And we got 50 grams of potassium chlorate. We got 50 grams of this guy. So first thing we need to do is a mole conversion. Well, I got 50 grams of potassium chlorate. Stick that over 1. I need to change that to moles. So 1 mole of potassium chlorate is how many grams? We need our periodic table for that, and we need a calculator. So potassium weighs 40 grams. Chlorine weighs 35. Oxygen weighs 16, and there's 3 of them. So we add all that up, and we get 123 grams per mole. Now, you could stop right here and do that math if you wanted to and calculate it out, but since we're doing dimensional analysis, we can keep on going. So I'm going to set up another proportion here. Once I got my moles of potassium chlorate, I want to change it to moles of oxygen. So I'm going to put my moles of potassium chlorate on bottom, and I'm changing that to moles of oxygen. Well, what's my ratio? There are 2 potassium chlorates for every 3 oxygen. So 2 potassium chlorate moles for every 3 oxygen moles. Then, once I got my moles of oxygen, I want to change that to grams of oxygen. So moles of oxygen go on bottom, and grams of oxygen go on top. Well, 1 mole of oxygen is how many grams? Well, 16 times 2 gives me 32. There is our string of math that's going to give us the answer. So we do 50 grams potassium chlorate divided by 123 grams. And that gives me 0.4065. I'm going to keep it going. I got to multiply by the ratio, which is a 3 to 2 ratio. So I'm going to multiply it by 3. I divide it by 2. And now I got 0.6097 moles of oxygen. But I need to know how many grams is that. So I'll multiply that by 32. And that gives 19.51 grams oxygen gas. And there's our answer. Now, if you don't like dimensional analysis, some people don't, some people do, there's another way you can do it. And that's just simply following these 3 steps right here. So let's redo that problem real quick, just using those steps. Now, this is typically not the way stoichiometry is taught, but in my experience, some people, if they can't get it, if they can't understand dimensional analysis, this usually helps. So first step is we convert to moles. So we said potassium chlorate weighed 123 grams. So 50 divided by 123, we'll round that to 0.407 grams potassium chlorate. Now I got to multiply by the ratio. What's the ratio? Well, the ratio is always the known to the unknown. So it's a 2 to 3 ratio. In order to find the multiple of a ratio, divide the right number by the left number. So 3 divided by 2 is 1.5. So that means there's 1.5 times the oxygen in this reaction than there is potassium chlorate. So multiply this by 1.5, and I get 0.6097. I'm going to round that to 0.61. And now it's going to be moles of oxygen gas. Third step is you convert your moles back to the unit of interest. So I want to multiply by the molar mass. Oxygen gas weighs 32 grams. And I get, once again, 19.51 grams of oxygen gas. Now, you don't have to do it that way. I've just had some students in the past that had a hard time with dimensional analysis, had a much easier time understanding it that version. It's typically not taught that way. As a matter of fact, some other educators don't like it when I teach it that way. I just like to show both just so you can choose which one you understand best. I recommend and highly suggest dimensional analysis, but if that ain't your thing, then just follow those steps and you'll get it. You'll get the same accurate answer every time. Let's do one last one. So we're going to combust 180 grams of glucose and see how much carbon dioxide and water will be produced by mass. So glucose combustion is C6H12O6 plus oxygen. It's going to be 6 of those. That's going to yield 6 carbon dioxides and 6 waters. So we got 180 grams of this sugar. We're looking for grams of carbon dioxide and grams of H2O. So we're going to have two separate strings this time. We got two separate answers. So let's just figure out the first one. Alright, so I got 180 grams. Just going to put glucose over 1. And I'm trying to change grams of glucose to moles of glucose. So grams of glucose go on bottom. Moles of glucose go on top. So 1 mole of glucose weighs, conveniently, 180 grams. So that means I'm dealing with 1 mole of sugar, of this glucose. This canceled out, left us with moles of glucose. So now I'm going to use this information to continue on. So I got 1 mole of glucose, and I want to change that to carbon dioxide. Well, we got to figure out our mole ratio first. Since sugar's on top, sugar goes on bottom. That leaves me with carbon dioxide on top. Now I need my ratio, my balance equation ratio. So let's look at it. There's 6 carbon dioxides for every 1 sugar. So 6 to 1. Once I got it to moles carbon dioxide, I want to change it to grams of carbon dioxide. So moles of carbon dioxide on bottom. Now I want to change it to grams of carbon dioxide. Well, 1 mole of carbon dioxide weighs 44 grams. So let's do that math right there. So I got 1 times 6 divided by 1 times 44 divided by 1. That's going to be 264 grams of CO2. There's my first answer. Let's do the next one. Give myself a little bit more room here, so I'm doing water next. So I got 1 mole of that glucose still, and I'm going to change it to grams of water. Well, got to set up my ratio again. So moles of glucose. This is going to be on bottom. Moles of water will be on top. That is once again a 6 to 1 ratio. I got 1 sugar for every 6 waters. So 6 waters to every 1 sugar. Then once I got moles of water, I need to change that to grams of water. So moles of water go on bottom. Grams of water go on top. So 1 mole of water is equal to 18 grams. So now I just do a little bit of math here. So 1 mole of sugar times 6 moles of water divided by 1 times the 18 grams. I get 108 grams. Get 108 grams of water. And there's my second answer. Hopefully this video helped you understand stoichiometry a little bit better. Remember, the best way to get better at stoichiometry is just practice, practice, practice. So find you some stoichiometry problems, sit down and work them over constantly, repetitively, and you'll eventually get the hang of it. I hope this video helps, and as always, good luck on your tests.